my 8th practicum of computer organization and architecture here. Let us dive into the practicum first. On first one, we shall start with the procedure itself on how to derive the DMA operations. So let us start from the procedure. The first step is to switch on the computer, and the second is to open MATLAB and create a new file and run the MATLAB script which is given below. And let us dive into the steps. The first step is to initialize memory, all 20 locations, all 0, and memory is equal to zeros, 1, 20, and after that step 2 is equal to generate random data from IO devices, which is from 5 values. Device data is equal to randy, and 199, 1.5, and after that we are displaying the initial memory and displaying the memory, and after that we are going to the third step, which is showing the CPU is free, where the data is not moving, and displaying that CPU is free, but the DMA will handle the data transfer. And on to the step 4, which is DMA transfers data directly into memory. Locations 1 to 5. Memory 1:5 is equal to device data. And step 5 is display updated memory contents. Display updated memory after DMA transfer, and we are displaying the memory. On to the sixth step, which is showing the data received from IO device, and on to the seventh step, which is indicating the completion and displaying the DMA transfer completed without CPU involvement. And after that, that's it. And here's the sample input of the code which I have explained before. Here's the initial memory. The initial memory is described as to all 20 locations, whereas the initial memory is 0, and the CPU is free, and DMA will handle data transfer. And updated memory after DMA transfer is you can see that only the first 5 values has been given. So here on to the second step, 199, 1.5. So here 81, 90, 30, 91, 63, and also 0. And data received from devices on to the next step given the and 81, 90, 13, 91, and 63, which is showing only the 5 values have been done, and after that DMA transfer completed without any CPU involvement, which is the 7th step. So there you go. This is the sample input, and the actual procedure is this, similar to the procedure which we have followed. Creating a new script file. Memory was initialized as an array of 20 locations. Random memory, then random data represented input from IO devices. Initial memory contents were displayed on the console. Message indicating the CPU was idle, and after that direct memory access DMA was stimulated from locations 1 to 5. Updated memory contents after DMA transfer were displayed, and the data received from IO device was printed, and final message was appeared. So here's the observation in which the initial memory values are given in the way that the data are all zeros, which is already present, and the data memory is it's like empty before DMA transfer, and after the device data is generated, more like for example, here's the 5 value which has been given, and it represents the IO device output, and after the DMA transfer the first 5 values are been updated, which is already shown there. And after that CPU stats, the CPU remains idle and confirms DMA bypasses CPU involvement, as clearly was executed in the previous one in the sample input. And the results are like the memory was initially empty with all values set to 0, and the random data generated from the IO devices was successfully transferred from memory locations 1 to 5, only 1 to 5. Others are like 0. The CPU did not participate in the data transfer process as indicated by displayed messages, and DMA mechanism efficiently updated the memory without affecting CPU performance. And the output, which is interpretation of the results is such that this experiment shows DMA allows direct data transfer between IO devices and memory, and the second one is that CPU was not involved in the transfer purpose process, but it remained free to perform other tasks. And the third one is the successful update of memory values confirms that DMA helps in the reduction of process overhead, and it basically boosts up the data movement, more like speeding up the processor. And onto the fourth one, which is it validates the importance of DMA. This result technically validates the importance of DMA in real world applications like multimedia and high speed data processing. And on to the conclusion, which is like basically what we have done and what was the conclusion. So yeah, the DMA solution was successfully implemented using MATLAB, which is of course we did it, and it was observed that DMA significantly improves system performance by reducing CPU workload. And if this experiment confirms that direct data transfer between devices and memory enhances speed and efficiency. Yeah, and it's proven that. And the final one is that DMA is an essential technique in modern computer systems, more like handling large data transfers such as multimedia purpose videos and audio and so on, and real-time applications. Yeah, so that's it. This is basically overall an explanation of this practicum, and there you go, and thank you.